It's a little loud, huh? We're going to finish talking about Mars today. And my focus today on Mars is going to be the search for life on Mars. So when I looked at these pictures, I have to tell you, first thing I thought was, is that like a tattoo on the one on the left? You know, somebody's skin with a tattoo. No, it's not. Now, I've rearranged the pictures quite a bit from the way they appear in the textbook, but these are all pictures from the textbook. These are pictures of dunes on Mars that have been...
Oh, I'm sorry. I'm like, what? I'm trying to see how I can see the dunes.
Well, if you look at the one, at this one, it's clear, you know, here's a feature that has shadow down on this side and light on that side.
But why does it look like that? Why the top is...
I don't know. At first I was like, ooh, is that supposed to be ice? But there was no discussion of ice. It simply says that it's dust that's been deposited by dust devils. Dust devils are a major part of the weather patterns they have on Mars. On Mars, the atmosphere is thinner than 1% of Earth's atmosphere. The atmospheric pressure on Mars, if I remember right, is 0.007 pounds per square inch. And on Earth, it's 14.9 or so pounds per square inch. So the atmospheric pressure is very, very low there. These dust storms have high-speed winds, but because the atmosphere is so thin, it doesn't push you around very much, if you were to be standing there, of course. It doesn't put as much force on things, but it does move a lot of dust around. And so that's a major factor in reshaping the surface. Remember, on Earth, we have slow surface evolution that occurs because of primarily water, and that is a secondary thing from the wind. Here, it's going to be the wind, even though it's very thin. The atmosphere on Mars is about the same composition as the atmosphere on Venus. That is, it's like 95% carbon dioxide. Should they be worried about a greenhouse effect there? No. In fact, they say that they have a refrigerator effect. A refrigerator effect because as the planet cooled, they believe scientists, within the first billion years of Mars' formation, because it's smaller, it cooled more rapidly, and the liquid or the water that it had froze and fell to the ground, and it can't sustain liquid water anymore. Its pressure is too low to have liquid water. It can have frozen water, ice, or it can have vapor water, but it can't have liquid water. And so they believe that's a primary reason why Mars is so different, because it lost some of its atmosphere, lost some of its greenhouse gases, which contributed then to its global cooling. And so as you lose the greenhouse gases, the cooling goes quicker, and that's why they call it the refrigerator effect. The refrigerator effect, in other words, is the lack of any greenhouse effect. Here are some pictures showing the land that has been kind of made into ridges by the wind blowing. So these long ridges, you can see it's called yardangs, are aligned with the dominant wind. And so you have these features, definitely signs of wind on Mars. You know, there's no question there's wind on Mars. We have the rovers out there. They've had all kinds of experience with the winds on Mars. Now, water. At the end, there's no question mark on water. I start with the stuff that is kind of more questionable in interpretation to get to the stuff that there is no question about. So you look at this. If you saw this feature on Earth, you would say, okay, this is likely the result of water. You know, you've had water that caused stuff to slide down the cliff and have landslides to make these features. Was it the result of water? I don't think anyone can conclusively say, but one might suggest that that could be a result of water. Here, some more features. What looks like features from having water flowing over a surface. And so scientists believe that these were like rivers, channels on Mars. So maybe there were some canali just long before Lowell. This here is actually the last picture of the chapter for those who followed along in the textbook. This is some features that are found on Mars, especially the picture on the right, which I know you can't see very well because of the lights. Still can't see that well. But you have striations there that looks very, very much like sedimentation that occurs on Earth when you have liquid water. You have liquid water, you put down layers, and they look very much like that. And so this is considered a good sign that there must have been liquid water on Mars in the past. So when I say signs of water, the signs of water with a question mark is, was there actually liquid water that sat on the surface, that flowed on the surface? We have no signs of current liquid water, but there are signs that there may have been liquid water in the past. Now this here is coming into more of the actual, yes, we see water. So this shows some frost on the ground. I probably shouldn't have put the question mark on this one. Frost on the ground. Scientists can analyze the composition, and so I'm pretty sure they've analyzed this to know that it's water. This here has definitely been analyzed. If you look here, you're like, what am I looking at? Or at least I assume you're saying, what am I looking at? What you're looking at is this stuff here that definitely looks like something has seeped out and flowed down the mountainside. And by spectral analysis, by analyzing the absorption and reflection spectra of those materials, scientists have determined that there is H2O, water, involved with those, probably a salt water. So there must be water inside of the soil that when it warms up, some melts, comes out, and you have that flowing before it disappears, right? Because in that pressure, you can't have water, liquid water, that is. The polar caps are really interesting. Remember from the homework that you just turned in a week ago, that Mars has a tilt that's very similar to the Earth's tilt, which means it should have seasonal variations similar to Earth's. Much less atmosphere, so you're not going to have the same thing. Farther from the sun, not the same thing. But you're still going to have a summer season and a winter season. And you have polar ice caps on Mars, just like you have polar ice caps on Earth. Now, the polar caps on Mars are actually different from each other. The South Pole has dry ice that is permanent. And there is some water mixed in with that dry ice according to spectral analysis. When it's the winter time, it will have carbon dioxide from the atmosphere. Remember, the atmosphere is 95% carbon dioxide, so what there is mostly carbon dioxide. It will freeze and fall and give you more of a ice cap that's a dry ice cap. In the summertime, you see what's underneath, which in the South Pole is still a dry ice cap. The South Pole's ice cap, I think it has an extent of something around 330 or so kilometers. So it's not a huge ice cap. During the winter time, the ice cap will extend down to 50 degrees. So it's a big ice cap during the winter time. But the permanent summertime one, not very big. Now the northern end, this is the north. The North Pole is quite a bit different than the South Pole. The North Pole has water ice. Now, of course, the winter time it's covered with dry ice. But it has a water ice cap, and that water ice cap is much bigger, extending for 1,000 kilometers. This is not the entirety of Mars, right? This is just a circular photograph that's looking at the polar cap. So Mars would continue on out here. Just want to make sure we don't have that misconception on the size of this. But you have H2O ice cap that's permanent there in the northern hemisphere on Mars. So have we found water on Mars? Most definitely we found H2O in the frozen form. We haven't found liquid water. We have signs that there used to be liquid water, but not now. This here is really cool. This is, see, a trench was dug by the Phoenix lander. What does it mean to dig a trench? It means you set the brakes on most of the wheels, and then you have a couple wheels that you spin. Well, this is one wheel. One wheel that you spin while all the rest of them don't, and that spinning wheel that digs the trench. And in this trench, you can see that they had ice, and there's time between these, 4 hours? 4 Martian days, not hours. 4 days, Martian days between these pictures. And you can see that some of the ice that was present in the first picture, for instance, this ice right here, is gone in the second picture. So the ice sublimed, that is, it went from the solid phase to the gas phase without ever passing through liquid. But clear evidence there of water ice on Mars. So there can be no argument, there is water on Mars. Not liquid water, but water. It is believed, now once again, this is looking at the same type of thing we saw before. So the stuff running down the slope, things like this here, that is the salty liquid water. And that once again leads to the belief that maybe underneath the surface, you might have regions that still have liquid water. Now, all of this searching for water, what's the point of searching for water again? See if it can support life. And so scientists have found some things that they suggest might be indicative that there has been life on Mars, but we don't have definitive proof that there was ever life on Mars. And I, of course, with my own personal bias, tend to believe that there never was life on Mars. But it's still an ongoing investigation. But let's focus on life on Mars. Anybody seen these pictures? I hate to admit, this is the next to last slide of my presentation. I apparently went way too fast in discussing these things. That's okay, we'll look at homework when we're done. This here, crud. I put another picture over this. Maybe I duplicated this and I have a second copy with the other picture over. But this is Cydonia, and that's the very famous face on Cydonia. So the picture on the left is a picture that was taken by the Viking explorer, or Viking spacecraft, and you can see that picture that looks very much like a face, right? And so many people, the book is pretty harsh about them, out to make a buck. I don't think it's as much people out to make a buck as it is people who are conspiracy theorists, say what they want to believe. You know, I can't remember if it's Agent Fox or Mulder now. But they believed that had to be, it could only exist if there was an intelligent being that created this. Does that make sense?
I don't believe it.
But he says, I don't believe it. Well, let's take a look at a lot of, well, I say a lot of us. General assumption, a lot of us probably are people who believe in creation. And one of the arguments that is made for, well, it's not a Christian argument necessarily, but a creationist argument, is the idea of, all of a sudden my mind went from ID to irreducible complexity, intelligent design. That's what ID stands for, intelligent design. Intelligent design is the idea that we have things that are complicated, that it's very clear they didn't happen randomly, there was intelligent design. You take something as simple as a bicycle. No one's ever going to look at a bicycle and say, wow, that just randomly occurred. Now, the intelligent design movement goes a lot more than just that. They say evolutionary processes are not guided processes. They're random. The idea of evolution as originally outlined by Darwin, is that you have evolutionary pressures, things in the environment that will make this variation have an advantage over this variation. Imagine, for instance, that there were trees that had lots of fruit, but the fruit was 7 feet up in the tree, and you couldn't climb the tree. So people who can reach up to 7 feet could easily pick fruit and eat well and provide for the family. But people who were only 4 feet tall couldn't reach the fruit. That's the kind of thing we're talking about for evolution. You have something that's going to favor this genetic trait over this genetic trait. And so you have survival of the fittest. The fittest is the one that's most likely to go on and reproduce, to have children. And so the taller people would be more likely to be able to eat well and reproduce. And so evolutionary theory would say that in that situation, because you're going to have a variation in genes, the people that have a variation for greater height are going to have more survivability, and over a few generations, you will start to have a bigger percentage of the people that are taller. It's just a drift in the genetic code based on what gives you an advantage. But as those drifts continue, the theory is that you will soon have big enough, well, soon, over time, have big enough changes that you now have a completely different species. Intelligent design people say, we look at things and we have irreducible complexity. We have things that you just couldn't have continuous variation to get here. You would have to have this particular piece and this particular piece at the same time. You couldn't have, well, this one gave an advantage by itself and then the other one gave a bigger advantage. You know, they say we have things that you'd have to have both pieces. A classic example is a mousetrap. A mousetrap, if you just have a spring, no good, right? You just have the board, no good. You just have the little lock, no good. You have to have all of those things together. So the idea that something like this would not occur without intelligent planners is essentially the same idea as the intelligent design theory. So it's not, since I believe in a creator, I have a hard time condemning the people who look at this and say, oh, that's a definite sign that there were aliens. The picture on the right, though, is a high-resolution picture taken by the Mars Global Surveyor of the same feature. And when you look at that, all you see is a random mountain. And so the scientists have concluded that the picture on the left that I put the red box around is just a coincidence of lighting and a natural feature. Kind of like when you look at the clouds and you see, oh, that looks like an angel. It's a coincidence. That's the scientific conclusion. Now, hopefully I have the other picture. Yes, there's the other picture. This here is an extended view of Cydonia. And you'll notice from the title, while this picture is obviously taken from NASA, it's not NASA who calls this the Cydonia Pyramid Complex. When you call it the Cydonia Pyramid Complex, what are you saying? Pyramids, how do pyramids exist? They had to be built. And so you look at this picture and it's easy to see you have features that definitely look like pyramids here. Right? That looks like a pyramid. That looks kind of like a pyramid. You have features, these here look like pyramids. They look like pyramids on Earth. We have Egypt where we have pyramids. We know those pyramids, well, I say we know. Most of us believe those pyramids were made by humans. Obviously, if you're into the Stargate world, you might believe that, Ra came down and the pyramids were the landing pads for the spacecraft. So, obviously that's not true. So it's kind of easy to see how people have concluded that there were humans or human-likes or aliens that might have planted humans here and planted humans, there. By looking at these features. Now, if you look online, I found a website when I was looking for better pictures of the face on Mars that had 7 different faces on Mars, things that shouldn't be there. People have nothing better to do than pore over those pictures NASA provides and find these anomalies. I call them anomalies. What am I saying? I have my belief, but I may be wrong. So I put these out here. I don't believe that there has been intelligent life on Mars, but you can see why people might believe that there has been intelligent life on Mars. Did you have a question on that? Okay, this is the absolute last slide. Anybody ever heard of the Nazca lines? These are not on Mars. These are, I believe it's in Peru. What country are you from? Brazil, right?
Yeah.
Okay, so not your country, as you said. These are in Peru. And these were not discovered until fairly recently. I think by people flying over, they're like, hey, there's these patterns on the Earth. And what they know about these is somewhat limited, but apparently there was a civilization there that made these very large sculptures, if you will, in the ground. And so these are intelligent designs that are put in the Earth. And if you look up Nazca lines, you'll find lots of different patterns. This is not the only one. There's like a monkey with a spiral tail, and there's what some people believe are landing strips, guides for the aliens to know where to land their spacecraft. There's a lot of stories that go with these. Remember the scientific idea. You find something interesting, you come up with a hypothesis that explains that it's based on scientific ideas. The alien idea, just like the God idea, is not a scientific idea. It doesn't mean it's wrong, but it's not a scientific idea. Science says there can't be things we don't know about, like aliens or a God. And so that's why it's not a scientific idea. It's outside of the realm. Doesn't mean it's incorrect. But this here, most people just say, wow, those people had a very interesting practice, probably religious, because what else would motivate you to do something like that? I mean, I doubt you're just out there for a prank, right? It's got to have some meaning. So you can see, once again, an analogy here between what we see on Earth, what we see on Mars, almost like a comparative planetology, for why people would believe that when you see a feature that looks like it might have design on Mars, you immediately jump to the conclusion that that must be a sign of some intelligent life on Mars. That concludes the chapter. So let's look at the homework, because we're only halfway through the class period. Why did I go so fast? I don't know. So how many people, if any, have had a chance to look at the homework? All right. 2 out of 7, that's a reasonable number. That's not Moodle, that's Moodle.
Only because I opened it when you mentioned it.
Oh, okay. Been looking at it for a long time, have you? We'll see if that logs me in correctly. Nope, didn't think so. That one. No. No. I'm meeting with great success.
You have the same question on here about the craters on this homework.
I went through and double checked every question. I did. I spent.
Okay.
How many questions are there?
There's 12, but one is like a 4 or 5 part.
Okay, that's the problem. I must not have hit save.
There's 12.
There were 2 repeat questions that I removed.
Oh, really? Maybe I have the wrong one. I'll check.
For chapters 8 through 10, correct?
Yeah. Okay, I'm not going to try to do this anymore. I'm just going to type it in because I do know my password as luck would have it. Don't be laughing. It's important. It totally doesn't want me to put my password in, as you can tell.
Okay, yeah, this is a different one.
Okay. Turn off LastPass. That removes. Where's the option to make it stop? Life is full of pain. Automatically fill login. And say you had 29 failed attempts. I'm logging now. All I want to do is some homework. We're into Moodle, by the way. Just, for those who are laughing along at home. All right. There's the questions. Only 10 of them. Because I took out the 2 that I had repeated.
Yeah, I had that one from the earlier one.
Yeah. Okay. Anyone have questions about any of these that we can talk about? Number 6. The moon was once closer to Earth than it is now. When it was at half its present distance, how long was its period of revolution? Sounds like a good question, don't you think? Just going to copy all these questions. Copy. Astronomy. So number 6. We are asked if it was at half its present distance, how long was its period of revolution? What is the period of revolution?
Are you talking about like 2 pi or what are you talking
Well, I just to make sure we understand what the question is asking. We have 2 periods we can talk about. What are the 2 periods? Okay, how long it takes to spin and how long it takes to orbit. When it asks here, it's asking about the orbit one. The spin one would have been, I don't know, was it still tidally locked back then or was it not? If it's tidally locked, then you have, similar answer. But if it's not, if it's talking about the orbit, then we have the equation that says period squared is proportional. Are you guys happy with T for period or do you prefer P for period? Which one are you comfortable with? P? So the period squared is proportional to the semi-major axis. I'm going to use R for radius cubed. Now I put proportional because it depends on the mass. You might recall that with Kepler's laws, Kepler had for his 3rd law that the period squared for a planet orbiting the sun in years is equal to the radius, average radius of its orbit cubed in astronomical units. But that was for orbiting the sun. But with Newton gave us an equation that applied to anything based on his equations, and turns out that it depended on the mass. That period squared over radius cubed was proportional to the mass. So this relationship of proportionality still works. So what I can do is take the period then the radius then, and divide those by the period now and the radius now. And when you divide, the proportionality becomes an equality. Because, if A is proportional to B, you double A, you double B. Well, if you do the ratio, then it will become an equality. So all we have to do then is say, well, we know the period then, we know the period now, we know the radius then. Actually, no, we're looking for the period then, aren't we? We know the radius then, we know the radius now, we know the period now. So I'm just going to take this, since I'm looking for period then, I'll square root both sides of the equation. And that gives me the period then over the period now is equal to, you guys may not be really good with this part of math, it's just nomenclature. Square root of something raised to the third power is equal to that thing raised to the 3/2 power, because the square root means raised to the 1/2 power. So it's easier for me to write this. And then I say, well, the radius then was 1/2 the radius now. So now I have to take 1/2 and raise it to the 3/2 power. That's going to be, well, square root of 1/8. Put it in the old calculator. So the ratio between the period then and the period now is 0.3536. So did it ask me for the actual period or the ratio? So how long is this period? So what's the last step? Period then is equal to 0.3536 times the period now. So I'm going to leave it to you to at least look up that period now and go ahead and use the sidereal period. That is the time to do one actual orbit, not the time to go from new moon to new moon for your answer. Mira.
Do we have what are the units for this?
I would use days.
Okay.
I mean, you could use hours, minutes, seconds, years if you delighted, but I would use days. If you use any of these others, then I'm going to have longer time grading. Okay, that was Clayton had a question. Anyone else have one they would like to look at? Speak now or leave early. You have two options.
What you said, what type of period you look up? Not
the sidereal period. That's the time to do one actual orbit. The time to do 360 degrees.
So just look up the sidereal period now?
Yeah.
Okay.
Because we were using the radius then is 1/2 the radius now. So. All right, well, do you have a question?
Yeah, I want to find one.
Julia is going to find one.
What about 5?
Okay, number 5. What is the relationship between Mercury's rotational period and its orbital period? That was one of the really interesting things. It can't be tidally locked like the moon because it has such an eccentric orbit.
Wait, what number is this?
5. Because its orbit is so eccentric, it can't be locked in so one side is constantly facing the sun. And so instead it's found a resonance where it does 3 orbits in the time it takes to do 2. Is that right? 3 orbits in the time it takes to do 2 rotations, or the other way around? It's 3 to 2.
Like 3 days.
Yeah, it does 1.5 rotations in 1 orbit. So it does 3 rotations in 2 orbits. Look it up to make sure that that's right. Remember, I went through the picture, it had the little nose on Mercury we tracked.
It's 3 days from 2 for 2.
Well, 3 rotations, not days.
Yeah.
Because this day turns out to be really crazy because of the situation. All right.
Wait, it does 3 rotation around the sun?
It does 3 rotations about its axis in the time that it takes to do 2 orbits around the sun.
Oh.
Yeah, it's pretty bizarre. Okay. Have a great Monday.